This video is on solving exponential equations. First, we need to practice with the rules that you'll need to be able to solve the equations that I'm talking about. So the first rule is a review of the negative exponent rule, and that rule is written in red above here. It says that anything to the power of a negative number is equal to 1 over that thing to the positive version of that power. So you can use this to change fractions into a number that has a base and an exponent, but the exponent will be negative. Let's take a look here. For example, 1 over 8. The first step, as you see here in the steps, is to rewrite the denominator as a perfect square or cube. So you look at the denominator, which is 8. And I know that 8 is a perfect cube. 8 could be written as 1 over 2 cubed, or 1 over 2 to the third power. Okay, once you do that, you use the negative exponent rule. And so we have something that looks like this. And all we're going to do is take it and say whatever's on the bottom, in this case a 2, we're going to make it to the negative power so that we have no more fractions. So instead of a 3, I'm going to write negative 3. So we're just using this rule. We're actually starting with this and we're ending up with something that looks like that. You try one here. Remember, step 1, rewrite the denominator as a perfect square or cube. So what can you do with the 16? I hope you recognize that 16 is 4 squared. Okay, now that you have that, look at what we did in the last example, and how would you rewrite this with a negative exponent so that there's no more fraction? Well, according to the rule, we take that denominator of 4 and we just make our exponent negative. So 4 to the negative 2 means the same thing as 1 over 4 to the positive 2. This takes a little practice, but it's really just moving things around, and I think you'll do great with it. The next rule we need to review is power of a power. And so this one is where you have something raised to a power, and then that's all in parentheses, to another power. And the rule is you just multiply the powers together. And so here I have an example, 25 to the power of x. The first step is to rewrite the base as a perfect square or cube and put it in parentheses. That's what this means here. So 25, I hope you recognize that as a perfect square. 25 is 5 squared. And so my step 1 says put that in parentheses and don't forget about this exponent that's here. In this case it's an x, but whatever was here you need to keep it. Okay, so now I have something that looks like this. And what does the rule tell you to do with the exponents? Well, it tells you to multiply them. So we're going to use the rule to multiply the powers, and we'll distribute if necessary. Well, here 2 times x is just 2x. There's no distributing necessary there, so we're done. Let's do one example that requires some distributing so you see what I mean. So for this next one, 16 to the power of x plus 2. Rewrite your base as a perfect square or cube and put it in parentheses. So 16, is it a perfect square or a perfect cube? I hope you said it's a perfect square. So what squared is 16? Were you right? All right, put that in parentheses, and whatever your exponent was here, it's still going to be here. So that x plus 2 is the exponent outside the parentheses. Now, here's the place where we multiply our exponents. But when you multiply 2 times x plus 2, you have to distribute it. You have to multiply it to the x, and you have to multiply it to the plus 2, which gives you plus 4. Oops. And so notice what happens there. You have to distribute. It's doing this, 2 times x plus 2. And we distribute by multiplying. Our answer goes there. We distribute again, and our answer goes here. So that one takes a little bit of practice, and of course you'll do some more in class. I want you to try this one on your own. Pause the video. Okay, so 4 is 2 squared, and I put that in parentheses, and 3x is still out here on the outside. Now I use my rule and I multiply. So my base is the same, that part doesn't change, but 2 times 3x is 6x. Do you notice that you distribute when there's plus or minus in the exponent? But if there's not plus or minus in the exponent, you just multiply the numbers. Okay, so now that you have the tools that you need to be able to solve exponential equations with different bases, let's get to it. To solve these, the first step is to rewrite the base on one or both sides as a perfect square or cube. So just what you've practiced a minute ago. Remember, your goal is to get the bases the same, so keep your eye on what you want the new base to be. After you do that, once the bases are the same, then you can ignore them and just set the exponents equal to each other. So let me show you what I mean. All right, I see 2 here as the base. I can't change a 2, but I can change a 4. A 4 is a perfect square, isn't it? So I could rewrite this so that this is 2 squared to the power of x minus 2. Now I'm going to come up here so I have some room. 2 to the 6th, that's okay. And what do I do with this power inside the parentheses and this power outside the parentheses? I hope you remember that we have to distribute it, multiply it to each piece. So this exponent of 2 times x is 2x, and 2 times negative 2 is negative 4. Look at our bases. Bases are the same. Once the bases are the same, you can ignore them and just focus on your exponents. So now I can pull that out, and I have 6 equals 2x minus 4. This is an equation that you can solve. Add 4 to both sides. Remember the equal sign. Use your little line down the middle if you need to. And I get 10 is equal to 2x. Sorry, this is hard to read. You want the x by itself. Keep your eye on where you're going. Divide both sides by 2, and I'm a little out of room here, but x is equal to 5. You can check your work by plugging it back in for x, putting it all in your calculator, and make sure that this side on your calculator is equal to this side on your calculator. Let's do another one together. This one, we're going to be using some negative exponents, and you know that right away because you have a fraction. All right, so 9 to the power of 5x. Well, 9 is 3 squared, but could you turn this 81 into something that has a base of 9? Isn't 81 a perfect square? So I may not want to mess with this 9 yet, because couldn't I take 1 over 81 and make it 1 over 9 squared? All right, and if I do that, 1 over 81 is 1 over 9 squared. Can I get rid of the fraction by using the negative exponent rule and writing that as 9 to the power of negative 2? Remember, 1 over something to a power is equal to that thing to the negative power. Okay, so wait a minute. I've just rewritten the whole right side of this equation. So the left side is still 9 to the power of 5x. But the right side I rewrote is 9 to the power of negative 2. Look at our bases. Once you verify the bases are the same, what do? Take your exponents, make them equal to each other. So now I have 5x equals negative 2. Well, we divide both sides by 5. We want x by itself. And you get a fraction. That's okay. X is equal to negative 2/5. This takes some practice. You will get it. Don't worry. I want you to try one. So keep your eye on the base. Remember your goal to get them the same. Pause the video and try this one now. Okay, so how do you think you did? Did you get an answer? I hope you tried it. You can't learn it if you don't try it. Even getting it wrong is better than not doing it at all. All right, I look at this and I see 49. That sticks out to me as a perfect square. 49 is 7 squared. All right, but I know that that's still to the power of 12, right? Okay, so what do I do with the exponents? Power of a power, I hope you said multiply them. So that's 7 to the power of 24. 2 times 12 is 24. But look, this side already has a 7 as a base. My bases are the same, so I get to ignore them now. And I have exponents that I'm going to box in, and I know that 3x is equal to 24. Divide divide 3 on both sides, and you get x equals 8. How did you do? I hope you got it. If not, make sure you ask me questions in class. You're going to get practice in your regular class today. You're going to be solving these in proof format in your regular class to help you keep track of your steps. So be ready to put this in a 2-column proof.